So we're going to go ahead and get started. So let's kind of turn down some of the side chatter. We're going to go ahead and get started. We've got some questions out of one to look at. And we're going to start with question 9. Okay, so let me write it down, and then we'll kind of kill some of the side chatter here. Okay, so let's be quiet, and we can go ahead and get started on the lecture. If you've got questions, feel free to ask. But we're going to start with question number 9. Now, question number 9 out of 1. What you got is this. Now, how would I handle this? This one has fractions. So, what do we need to do? We need to solve it, right? And we need to clear the fractions. And what technique do we use? We can cross what? Yep, cross multiply. Okay, so we're going to go ahead and cross multiply. And if I cross multiply, what does that give you? That gives you 7 times your x plus 2 equals 3 times your x plus 4. Is everyone okay with that so far? Right? Now what do? I'll go ahead and finish this one out because there's not much to it. We distribute. Okay, so take your time and distribute through here. So distribute that 7 through, and that's going to then leave you with a 7x plus 14 equals now 3x plus 12. Solve it by moving that 3x over, and move that 14 over as well. So 7 minus the 3x, that leaves you with a positive 4x. 14's cancel. The 3x's cancel. And 12 minus 14, that leaves you with a what? Minus 2. We'll divide by our 4, and then we'll reduce that down. And that reduces down, and that gives you now x equals minus 1/2. I'm not requiring you to write it down, but what type of equation would this be? Conditional, contradiction, or an identity? Does anyone remember? This would be conditional. Why? Because we have an answer, right? When you solve it and you get an answer, that means it's conditional. Yep, that's question 9, and that's out of 1. So that's question 9 out of 1. Question 14 is the next one out of 1 that we'll look at. And this is one that requires you to work through the interest problem, the interest formula. And we're going to talk about simple interest. So what we've got is we've got a loan. Now later on in this course, we're going to learn about compound interest, and that's how most banks and financial institutions charge interest. But we're going to look at this one in terms of simple interest. But later on, when we get to the later chapters, we'll talk about compound interest. So for this one, what we need to be careful of is we need to make sure that we have our time in terms of years, not months. So for question 14, I'm going to set it up, and I'll let you finish it. So for question 14, Levi borrowed $7,129, 4% interest. He's doing this for 6 months. We want to know how much he has to pay in interest and the total amount. So how do we set this up? Well, we go back, and I always like to write up our formula. So our formula is I equals PRT. And P is the principal, so the starting amount. Okay, and so what's our starting amount going to be? Well, that's going to be, can someone tell me? What would that be? Yep. Yep, that's going to be your 7129, isn't it? Yep. Yep, no problem. R is going to be the rate, and we always want to make sure we put that rate as a decimal for the percentage. So it's 4%, and make sure you're careful. As a decimal, that would be 0.04, wouldn't it? And our time. Now, Time is in years. And in this case, we've got 6 months, so we have to divide that by 12. And that's a half. Or you could even use 0.5 for that. So is everyone okay with how I got the pieces on that? And you can either use a half or 0.5. Either way will be fine. And now we're going to go ahead and plug in our value. So to find our interest, all we have to do is multiply these together. And I'm going to leave this for you to finish. But you've got most of it worked out. I'm going to leave that for you to finish. And again, if you don't have all the homework done today, you can turn it in on Thursday. If you want to go back and rework some of them and correct them, you can turn them in on Thursday. If you've got it done today, I will collect it today. But if you want to hold off and turn it in on Thursday, you can do that as well. So that was question 14. Let's now move on and look at some questions out of 1.2 now. And we'll start with question 4. Now again, on these, I am not going to work them out completely. We're going to talk about how we come up with the equation. Because normally students do not have trouble solving them. It's a matter of how do I get my equation. So we're really going to focus on these because I know students struggle more with the applications than anything else. And we went over some of these last time, but let's talk about question 4 again. All right, and question 4 is a mixture problem. So we're going to have to make a diagram. Then we're going to have to build our equation from there. Let me adjust the focus so it's a little bit clearer here. Okay, I think I'll adjust that focus a little more. Yeah, that looks a little clearer, I think. Okay, so yep, that's going to be a little bit clearer. So we're going to look now at question 4. So what are we doing here? When we talk about these mixture problems, what do we have? When we talk about mixing the chemicals together, we have 3 things that are involved. How much is in there? So how many gallons, how many milliliters, how many liters? So that's your amount. You have a concentration, a percentage rate that's associated with it, right? And then when you multiply those together, you get the amount of pure. So when we talk about pure, what is that? Okay, so let's say we've got a salt solution. Pure would mean if I boil out the water from that salt solution, how much salt is left? That's your pure. You took out all the water. So when we talk about pure, that's what you're doing. It's having a salt solution and boiling out all the water, only leaving the salt. How much salt you have, that is your pure. So we're going to talk about this, and we're going to take our time with the setup. First thing we always do is we read it. Okay, read it through once. And then once we've read it, then we go back and we look at each piece individually. So let's start with question 4. In a chemistry class, 6 liters of a 4% silver iodine solution must be mixed with a 10% solution to get a 6% solution. So we need our 3 boxes. So we start always with our 3 boxes for this. And we're going to take our time and talk about each box and where each component goes inside the boxes. And the boxes are always labeled 1, 2, and 3. And this is your amount, and this is your percentage rate. Box number 3 is always what we want. So when we are finished mixing these together, that is your box number 3. So let's see what we've got. We read it again. In a chemistry class, 6 liters of a 4% solution. All right, so 6 liters of that 4%, that's what we start with. So 6 liters of the 4% is going to go here. So 6 goes there for the amount, 4% goes below. So that's your first box. We are then going to mix that with what? We're going to mix that with a 10%, right? Now, when we read it, does it tell us how much 10% we need? No. So the amount of the 10% is X, and we know that concentration is 10%. So is everyone okay with that? The way we've got them set up, we've got amount, we've got percentage rate. Now, amounts always add. The way I remember is 1 plus 2 is 3. So these go together, and that gives you then X plus 6 there. Now, what about the percentage rate? What do we want to end up with? We want to take a 4%, mix it with a 10% to get out a 6%, right? That's what we want. If we read it, it says, in a chemistry class, 6 liters of a 4%. So that's here. We're going to mix that with an unknown amount here of 10%. And what do we want to end up with? We want to end up with what? 6% over here. So is everyone kind of okay with how I did that? Take your time, read it, think about each piece individually. Now we build our equation. So once we have that, we can now build our equation. And we build our equation based on the pure. And the pure is the amount times the percentage rate. And so on our first one, amount times rate, okay, that's 6 for the amount for the first one, and the percentage rate as a decimal. Be careful with the decimal. That's going to be 0.04. What about the second one? How much is in there? Unknown amount X. What is your percentage rate? 10%. So that's 0.1. Unknown amount X goes with it. What about the third one? 6%. So that's 0.06. How much is in there? X plus 6. And you can finish it from there. So hopefully you know how to finish it. You'll multiply, distribute through that 0.06 and solve it. And these just take practice. That's how you get good at setting them up, is just practice them. And I know students always struggle with these, but it's something you just have to kind of work through. We don't have a lot of applications. There's only 2 major sections. 1.2 and 1.5. Those are the only ones that have a lot of applications. So now let's look at question 6. Okay, now question 6 is going to be an investment question. So we're investing money. So what we've got for question 6 is we've got Marty, and she received an inheritance of $50,000. Part of it went at 1.75%, and the rest went at tax-paid bonds at 2%. Her annual income from the 2 investments was $900. So what are we going to do? Well, we're going to set it up in a similar way to what we did with the last one, only instead of containers of liquid, we now have money. Now, we need to make sure that we do not get the total amount invested confused with the interest. So make sure you know the difference between the interest and the amount of money in that account. So we always work with the amount of money first. Interest is at the end. So question 6, Marty received an inheritance of $50,000. So what is that $50,000? That is not your interest, is it? $50,000 is how much money I've got to invest. So that goes here. Total amount is over here. Is everyone okay with that? Right? Total amount of money goes on the right-hand side, right here. What about the interest rates? Let's talk about those next. We've got two different interest rates. 1.75%, which is here, and 2%, which is over here. Now, do we know how much money, because this is your rate here, just so we got them labeled, do we know how much money we have in the 1.75% account? Does it tell us at all? No. All right, so that's going to be our unknown. So we're going to put an X here. What about the second one? Do we know how much money is over here? No. Well, we can't just reuse the X again. So the second one is always going to be the total minus X. And how much total money do we have? It's 50,000. So that's going to be 50,000 minus X. Now let's build our equation by looking at the interest. And the interest is the amount, again, times the rate. So I'm going to build the equation, and you're going to have to finish it. So let's start here. On the first one, amount times the interest as a decimal. So the interest is 1.75%, so be very careful with the decimals. That's 0.0175 as a decimal, and bring down the X with it. Those go together. And then we've got our second one, which is 0.02 for the percentage rate, times your 50,000 minus X. And on the right-hand side, this is the total interest. Bless you. And how much total interest do we make? Not the amount of money, right? Total amount of money is 50,000. How much money did we make in interest? We made how much? Looks like 900, wasn't it? So that's going to go there. You can finish it. It's all set up, but you're going to be responsible for finishing it. Is everyone kind of okay with how we're setting these up? The only way you get good at these is to just do a lot of them. And I'm sure you've seen these in many classes before. They're all kind of set up the same way, though. Okay, we got a couple more to look at. So that was question 6. Now we'll look at question 7. We're going to set it up as well. Okay, question 7 is next. And let's read question 7 and see how it's all going together. So question 7, very, very similar to question 6. Only difference really is the numbers involved. So Walt made $10,000 last year from his part-time job. So that $10,000, that's going to be your total amount. Okay, that's how much money we've got. He invested part of the money at 2%, part at 3.75%. Total amount was $270. So, very, very similar to question 6. Almost the same, just different numbers. And let's start off with our total amount. Okay, so we're looking at our total amount here. So how much total money do we have to invest? If I read this one, it looks like I've got a total of $10,000, right? Okay, is everyone okay with that spot? Now, each of these is going to have an amount and a percentage rate. So, what do we know? Well, what about our rates? What two rates do we have here? We've got a 2, right? And we've got a 3.75%. So let's put those down. And do we know how much is in the 2%? Is that given to us at all? Nope. So that's going to be our unknown x. And what about over here? Does anyone know what's going to go with the 3.75%? What goes here? Okay, that's going to be what? Anyone got any ideas? That's going to be... Okay, look at the last one. What about the last one? What went with the last one? 50,000 was here. This one was then 50,000 minus x. So look at the pattern. This one's 10,000 here. So what's going to go here, do you think? It's going to be 10,000 minus what? Minus x. Yep, someone said it. Now we can build our equation. So now we look at the last one, and we do the same procedure. We need our interest. And interest is the amount that we have times the rate. And our first one, converting, that's 0.02x there. Second one, that is 0.0375. And how much is there? 10,000 minus x. And then what about the other side? How much total interest did we make? We made 270. So that's what we've got there. You can finish it. So distribute through and finish it out. And we've got two more, question 8 and question 9. So let's get back on track here. Okay, so question 8, a little bit different, but still same kind of concept. Again, we're going to be investing. This one is a little bit different than the last one. So Roberto invested some money at 2.75% and 4,000 more than twice this amount at 3%. He made $1,257.50. How much was invested at the 3%? So, starting out, what do we know? When we read this, we know it's an investment question. So that means we've got to draw our dollars here again. And it does not tell us a total amount. So we don't have a total yet. But let's look at each one of these, and let's look at the amount and also the percentage rate. So we can take our time. We're going to look at this. It said Roberto invested some money, 2.75%. So do we know how much money is in the 2.75% accounts? No. All right, so that's our unknown, so that's going to be our x. So our amount here is x. Percentage rate is 2.75%. So we broke it down into smaller pieces. So that's the first part. What about the second fund? 2.75, unknown amount, we have that, and 4,000 more than twice this amount. So 4,000 more than twice this amount would be 4,000 plus 2x, right? 4,000 more than twice that amount is going here. And what percentage rate do we have over here? Well, it looks like we've got 3%. We're going to go ahead and add these across to get our total amount. And when we add these across, we have now 4,000 plus 3x. So that's what happens when we add them across. We'll build our equation. And answer the question. So what does it look like now? Well, we're going to look at the interest here. Interest, again, is the amount times the rate. And the first one. Make sure you're careful when you convert these. Interest rate is 2.75%. So as a decimal, that's 0.0275. And how much is in there? Unknown amount, x. Okay, so there's that piece. Second one, 3%, so that's 0.03. How much is in there? 4,000 plus 2x. And what does it give you for the total interest? That comes from the question. Total interest is $1257.50. So there is your equation. Now you're going to have to finish it. I don't believe in finishing questions out for you. What I do is work it out, make sure we understand how to set it up. It's your responsibility to finish it. So we only have it about half done. Question 9. So question 9 is an easy one. All you're going to have to do is plug the numbers in. I think we did question 10 before last class period. So we're going to look at 9, and we're looking at a linear model. And this linear model projects the sales of a number of toys we have. Because as you introduce a toy, it has a lot of popularity, and then people buy the toy, and not as many are made and sold. So that's why this is a -2 here. So we've got this model, and it's used to predict the decline in sales of a toy after it has been on the market for a year. X is the number of months after the first year, and Y is the number of toys sold in hundreds during that month. So let's talk about our equation and how to set it up. And we want to know how many are going to be sold 11 months after the first year. So here's our equation. Y equals now minus 2x plus 380. X is number of months. Okay. And we've got number of months. And then Y is toys sold, but it's times 100. Yep, and I'll move that up so you can see it. Sorry about that. Just wasn't paying attention there. So this is what we've got so far. So we've got X is the number of months that it's been on the market for. Y is the number of toys, and that's going to be times 100 because it says number of toys sold in hundreds. So when we solve this, we're going to have to take our answer and multiply it by 100. So it's not going to be just the answer. You're going to have to multiply it by 100 because this is the number of toys sold in hundreds. So take your answer, multiply it by 100, or just tack on 2 zeros. Now, what are we going to use? Well, we want the 11th month. So that means X is going to be then what? 11. Okay, so you plug in your 11. And then you can finish it from there. Now, when you get your answer, multiply that answer by 100 because Y is in terms of hundreds of toys sold. So you get your answer, multiply it by 100. So it's going to be several thousand. Is everyone okay with that? So you just plug it in, get your answer, multiply it by 100 because toys are in hundreds in this case. Well, let's go ahead now and talk about the next section. So I'll go ahead and pass out the next homework packet. And if you want to turn in your homework, just make sure I get it before you leave today. Or you can turn it in again on Thursday. The thing is you do not want to get too far behind. If you've got it done, I'll collect it. Yeah, you'll get full credit on Thursday if you turn it in. So if you want to go back and rework things, maybe you weren't sure how to do some of these applications. Maybe you got 4 or 5 of them done, but you want to go back and finish them, finish the ones we went over, you can do that. Just turn it in on Thursday, and I'll give you full credit for it. I don't take off points for late work. You just do not want to fall too far behind. So you want to try to keep up and try not to fall too far behind. So I'm going to go ahead now and pass out your new homework packet that's due on next Tuesday. I'll go take, otherwise you turn it at the end. So if you got your homework, you turn it at the end. Right now, just make sure I get it early. If you want to turn it on Thursday, you can do that. Also, when you turn in your homework, when you turn in your homework, oh, got it. I'm waiting. Yep. Everyone else got it? Okay. When you turn in your homework, make sure you put your name on it. So when you turn in your homework, please make sure you put your name on it. Let's double check these real quick just to make sure. Yep, it's right. Okay. So let's now go ahead and start the next section. And the next section, I think you're going to find it to be a lot easier. The next section is 1.3, and there's really not a lot to do. 1.4 is going to take us some time. So what we're going to do today is we're going to get through 1.3 and then probably about half of 1.4. Because 1.4 is a section that has a lot of material in it. So we're going to go ahead now and look at 1.3. 1.3 is a very, very easy section. There's very little information in 1.3. Now, 1.3 is complex numbers. We're going to talk about what complex numbers are, how to write them in the correct order, and then we're going to also learn about the imaginary component of these complex numbers. So the first thing we're going to look at is our definition. And this is just something that we have to use. I by definition, is defined to be the square root of a negative 1. This is the only definition you really need in this section. I'm not going to make you multiply complex numbers out or divide. We're going to learn how to write them in the correct order and what they are. So I is defined to be the square root of a negative 1. Now, in previous math courses, you probably never worked with the square root of a negative number because you were told that's not possible, right? It's not a real number. Well, what is it? Well, in this course, we're going to talk about it. And in this course, we define I to be the square root of a negative 1. Now, that comes into play when we have square roots and a negative underneath them. We can rewrite them as an I. So we're going to start off with a few simple ones. So let's learn how to simplify some square roots down. And we'll start off with a very, very easy one. Let's try to simplify or break down the square root of a negative 25. Well, what's the square root of 25? 5. Okay? Now, the only difference is there's a negative underneath this square root. So that tells us then that an I comes out. So that would break down to be simply 5i. Okay, this is 1.3. Let's do another one. What about the square root of, how about an easy one here? How about negative 16 underneath the square root? Okay, well, what's the square root of 16? 4. It's negative underneath the root, so what comes out with it now? I. Those were all perfect squares. If they're not perfect squares, we're going to have to break them down a bit. So let's do some more of these. This one we're going to have to break down. This we're going to have to factor it out and see how we can reduce it. How about the square root of, let's put a minus in front. How about 80 underneath the root? Now, this one is not going to have an I on it. Why not? Because the negative is out in front. Okay, so it's a real number. These are imaginary. This one's going to be real. How does 80 break down? Well, first off, 80 is not a perfect square, is it? So we need to break 80 down. Now, we look for squares. We look for pairs. So we're going to take our 80 and we're going to break it down. Now, you can break it down any way you'd like. It ends in a 0. So I'm going to do 8 and 10. Easy enough there. And 8, we can break that down into 4 and 2. And 10, we can break that down into 2 and what? 5. And then the 4 over here, well, that can be broken down further into 2 and 2. Now, once we have it broken down, we're going to circle our pairs. So we have a pair of 2's and another pair of 2's. And we multiply those together. So out in front, we have a negative. That just came along with it. So that just got drug along. So that's your negative there. And what do we have? We have 2, right, from here. We have another 2. And then what's left over that we didn't match up? We didn't pair up? 5. We can break this down a bit because 2 times 2 makes it a 4. And the square root of 5 stays in there. Why does it not have an I? All right, the reason why it doesn't have an I is because that negative was out in front. If it's out in front, it just comes along with it. If it's inside, then we have to bring out an I. Let's do a couple more of these. This is the hardest part of this section, is just breaking up these roots. So this is actually the hardest part. Let's do some more of these. How about the same directions here, simplify. How about a minus, square root of minus. Make up one here. Let's see. How about square root of 98. So we'll do a negative 98. Now, I picked this one on purpose because we have to remember how order of operations work. I cannot cancel these negatives out. Why not? Because one is underneath the root, okay? One is out in front. You can, when you only cancel when you multiply. Well, square roots have to be done first before you multiply. That's why we can't cancel them out, because the roots have to be done first. So the negative inside is actually going to come out as an I. I stands for imaginary. So we need to first break down the 98. So how does 98 break down? The way I begin is I look at it. 98 is an even number, so we're going to start with 2. 2 and 49. And we're in luck because 49 is a perfect square of what? 7 and 7. So now we're going to circle our pairs. We bring the negative out in front along with it. Okay, so that's coming here. So that's where this negative goes, out in front. We have a 7 out in front. Now, we have an I outside. Why? Because there is a negative underneath the root. So that's going to be a negative 7. We bring out an I, and what's left over that didn't pair up with anything else? 2. So that is going to come out as a minus 7I square root of 2. And we normally write the I in front of the square root. So if you have a root, you write the I in front. Let's try another one. In some cases, they may not break down at all. Right? Some of these may not be able to be broken down. So let's try this one. And this can happen. 19. If I try to break down 19, now 19 has nothing in it. The only factors of 19 are 19 and 1. That's it. So 19 won't break down at all. The only thing that we can do is we have a negative here, so the negative can come out as an I. So I could write this as I square root of 19. And that is all I can do with it. Okay, that's it. Now that we've seen I and how I works with these roots, now we're going to talk about numbers and how to classify them. And this is going to go back to questions 1 through 3. We already did 4 through 7. We've done those. We're now going to look at 1 through 3 in your homework. So let's talk about how we classify these numbers. In previous courses, you stopped at real numbers. All right, in this class, we're going to go up to complex numbers. And complex numbers are all the numbers. So complex numbers are everything. So all numbers are complex. So all numbers are complex. Now, when we classify numbers, we classify them kind of like a botanist would classify plants. Okay, so when a botanist classifies plants, all plants are plants, right? Shrubs, trees, whatever they are plants. When we classify numbers, all numbers now are complex, so they're at the top. And we can take our complex numbers and we can break them down into real and non-real complex. So everything is complex. So complex is at the top, and we can split complex down into real and non-real complex. Now, what are non-real complex numbers? Well, these have an I. So when we talk about non-real complex numbers, these have an I. They have an imaginary part. So when we talk about non-real complex, they're going to have an imaginary part. They have an I. The real part we're not going to break down anymore. And we can then break the non-real part down one more step into pure imaginary. And pure imaginary, they only have an I, so no real part. So we're now going to look at some numbers, and we're going to classify them. Now, these numbers are going to be classified as more than one type. And they'll make more sense once we start actually classifying them. So we've got complex, and then we have real or non-real. And if they are non-real complex, then they can also, in some cases, be pure imaginary. So I'm going to give you some numbers, and we're going to talk about what they are and how to classify them. So we're going to classify the following. Eight. So let's look at 8. What about 8? Okay, is 8 real or non-real? And what I mean by non-real is it has an I. Does 8 have an I anywhere near it at all? No. Okay, so 8 is real. Now, once you've classified it as either non-real, complex, or real, you have to follow it up. So this is going to have two types. What is it? It's real, and you follow it up. It's also complex. So this would be real, and this would also be complex, right? No imaginary part. Anytime you have an I, that's an imaginary part. And if you've got a square root, you may have to break it down if you can. So what do we know about the square root of a minus 49? Well, 49 is a perfect square of what? 7. It's negative underneath, so what comes out with it now? An I. Okay, now, is this real or non-real? We'll start with that. Okay, it's non-real. If it's non-real, it can also be pure imaginary. So what do I mean by pure imaginary? Okay, pure imaginary means it just has an I part. Not anything else, not a real part, just an imaginary part. So this one would be pure imaginary, and you follow it up. This one is also non-real complex. And everything is also what? Everything is also complex. So that is how you would classify the square root of negative 49. Let's do another one. Eight minus 9i. Now this one's a little bit different because this one has both a real part and an imaginary part. The 8, the number out front, is the real part. And the 9i, well, that's your imaginary part. So this is a non-real complex number, and it has a real part, and it has an imaginary part. Now, unlike the last one was pure imaginary because there was no number added in front. Okay, so this one has a real part, which is out in front, and it has an imaginary part. So this one would be non-real complex again. Anytime you have an I, it's non-real complex. And we followed up. What else is it? It's also complex. Now, why is it not pure imaginary? Pure imaginary would be like that. If I covered that 8 up, that would be pure imaginary. Pure imaginary means it just has an imaginary component and no real part. This one has both a real part and it has an imaginary part. Let's do 2 more just to make sure we have these down, because these are very easy to do. They're not difficult at all. It's just classifying. What about the square root of 15? Can I break down the square root of 15? No, because what does 15 break down into? 3 and 5, right? We have no pairs. So we can't break it down. Now, is this a real number or a non-real number? Which one? Are we going to bring out any i's at all? No. So this would be real. Okay? If it's real, what else is it? Okay? Real and complex. So this one would be both real and it would be complex. Okay, let's look at this one. Now, resist the urge again to cancel those out. We can't. Can we break down the square root of 2? No. Many times you won't be able to. So we can't break down the square root of 2. But we have the negative out in front. So that's coming along with it. So that's there. Now what about this negative here? What does that do? That comes out as an I. So we put the I in front. And what's left over? Square root of 2. All right, so what would this be? Is this real or non-real? Non-real. Is it pure imaginary? Yes. Okay. Pure imaginary means you only have one part. So this just has an imaginary part. So this would be pure imaginary, and we'll look at the difference again in a moment. But this was pure imaginary. It's non-real complex. And it's also complex. Okay. Let's make sure we know the difference between something that is just non-real and pure imaginary. So these are going to be pure imaginary. 5i minus 8i, 4i, I square root of 7. Those are called pure imaginary, all right? Because all they have is an imaginary part. These are not pure imaginary. Four minus 7i. 8 plus 2i. 9 minus 4i. Those are not pure imaginary. All right, and they're not pure imaginary. Why not? Because these have a real part out in front and an imaginary part behind it. Do you see the difference between a pure imaginary number and something that's not pure imaginary? So these are just non-real complex here. These are also non-real complex and pure imaginary. But you see the difference now. When we go to work with complex numbers, we write them in what are called standard form. And this is standard form of a complex number. when we talk about standard form of a complex number, we have a real part and an imaginary part. And the A is the real part, and the BI is the imaginary part. So when we write our complex numbers, we have to make sure that we have the real part first, then the imaginary part. And the imaginary part is going to have an I on it. This is just the way we write our complex numbers. This is the only part that you're going to need when you look at 1-4 with the quadratic formulas. We'll do that on Thursday. We need to know how to write our numbers in standard form. So I'm going to pick a few of these from our textbook now to look at. So we're in 1-3, and I'm going to pick a couple of these for us to rewrite. We'll probably do 3 of these, and then we'll move on to 1-4. So I'm on page 130. And we're going to look at question 41. And I'll write them up on the overhead so you don't have to use your textbook if you don't have it with you. So let's talk about how we would work this one out. Now, what we want is we want to write this in standard form. So we want it to look like this. A real part separated by an imaginary part. So what we do is we break up our square root first, if possible. So if we can break up the square root, we do that. And 24 is going to break down. And you can break it down however you would like. But we can break 24 down into 4 and 6, right? And we know that 4 is a perfect square of 2 and 2. So those are going to get circled. Now, what about 6? 6 I can break down into what? 2 and 3, right? But am I going to have any pairs with that when I break the 2 and the 3 down? No. So what's this going to break down into now? We've got a -6. We've got the minus that comes down from here. We've got a pair of 2's that comes out. We've got a negative here, comes out as an I. What's left over? That didn't have any pairs with it. The 6 comes, or no, sorry, the 6 stays inside. And what's down below? 2, it stays there. Okay, because I could break the 6 down into what? 2 and 3, but we don't need to because there's no extra pairs. So anything that's not paired up just stays underneath that root. Now we've got one more step. We break it up into individual fractions and we reduce. So we break it up into individual fractions and we split them up. -6/2. What does -6/2 break down into? -3. On the next one, the minus comes down. The 2's, they can cancel. So that leaves you then with I square root of 6. And there is your answer in standard form. The real parts first. Imaginary parts behind it. Now, normally what I do is I put the I in front of the root. The reason why I don't put it behind is students would then think that it's part of the root. So I always put the I, the imaginary part, in front of the square root. We're going to do 2 more of these just to make sure we understand the concepts, and then we'll move on to 1-4. We're not going to finish 1-4 today. We're only going to barely touch on it. We should have a little bit of time to do some out of 1-4. So that was 41. Let's look now at about 44. So let's look now at 44. Same page. question 44. Same directions, same page. We want to break this down into standard form. So 8. How does 8 break down? Okay, 8 breaks down into 2 and 4, and then what? 2 and 2. So we want pairs. So what do we have? We have a pair of 2's, so that comes out. We have a negative underneath our root, so an I comes out as well. And what's left over that doesn't have a pair? 2. So that's left over underneath that root. And that is all over now what? 2. Break it up into individual fractions, and then you reduce. So what we do is we break it up into our individual parts, and we reduce them. So 20 over 2. What would 20 divided by 2 reduce down into? 20 over 2 is a 10. Okay. And then the 2's can cancel here. And that leaves you with an I square root of 2. So that's our final answer in standard form. 10 plus I square root of 2. One more. Let's look at question 45. So the next one here, question 45. Very important that we know how to break these down, because you're going to be doing this in 1-4 when you work with the quadratic formula. Which that'll be on Thursday. So minus 3 plus the square root of a negative 18. And in this case, it's over 24. So the first thing we have to do is work with our root. And 18 is going to break down into 2 and what? 2 and 9. And now, why did I not use 3 and 6? I could have used 3 and 6, right? But I know that 9 is a perfect square of what? 3. So we want to try to use as many squares as we can. You could still do 3 and 6 and get the same answer. But I noticed that 9 is a perfect square and it goes in there. So that's 3 and 3. So the 3's get circled. So we have a minus 3. Now we have a plus. 3 comes out. I comes out because of the negative here. And what's left over? 2. And that's over now 24. Rewrite and reduce it down as much as possible. And 3 out of 24. Well, 3 out of 24, what would that reduce down into? That's going to reduce down into now, when we break it down, that's going to reduce it down into 1/8, right? Because 24 has a 3 in it. So that's going to reduce that down to a minus 1/8 there. That's the real part. And then what about the imaginary part? Same thing here. It's going to leave you with an 8. And you can write it a couple of different ways. I'm just going to write this as the square root of 2 over 8. And then I'm going to put the I behind. You could have put the I in front right here. Normally with fractions, though, I put the I behind. And I'm not so concerned about that as long as the I is there. As long as you put the I there, I'm all right with it. But normally with the fractions, we would put the I at the end. If you don't have a fraction, it goes in front of the root. But as long as you manage to get the I on the page, that's all that really matters. Now we're going to move on, and we're going to look at a little bit out of 1-4. We have a few minutes, and we're going to look at a little bit of 1-4. We're going to cover most of it next class period, but I want to at least get through part of 1-4. 4 here. And the part that we're going to look at is the square root property. So in 1-4, there are 3 basic ways we're going to learn how to solve equations. These are nonlinear equations, and we're going to learn how to use zero factor. We'll review and go over zero factor on Thursday. We've got the square root property, which we're going to learn today, and the quadratic formula is going to be on Thursday as well. We don't have enough time for zero factor, so we're going to do the square root property today, and we'll pick up zero factor and the quadratic formula on Thursday. So the middle questions there, 6 through 10, is what we're going to be going over right now. And this builds on what we have just talked about. Now, when we solve equations, we think of opposites. In fact, the opposite of addition is subtraction. The opposite of multiplication is division. When we solve squares, what's the opposite of a square? Well, the opposite of a square is going to be a square root. So a square will cancel out a square root. However, when we take a square root, we've got to add on a plus or minus, because we're going to end up with 2 solutions. The power tells you how many solutions at most you'll have. So if you've got x squared, that means you can have up to 2 solutions. And we're going to have to use a plus or minus. Now we're going to start off with some very, very simple ones. And let's just do one where we just apply our square root property. So say I want you to solve x squared equals 81. Now it is squared. Okay. How do we get rid of a square? The opposite of a square is a square root. Now whenever we take a square root, you've got to add in a plus or minus. Why? Because when you square a negative number, it becomes positive. So you have to make sure you get both sets. The square root of a square is just itself. So x squared, when we take our square root, would come out as an x. And what's the square root of 81? 9. So that would be x equals plus or minus 9. Not 9i. Now, look at question 6 in your homework. What's the difference here? What's the difference between this one and this one? Just the negative, right? And if it's negative, when you take a square root, what does it come out to give you? I, right? So this one would be a little bit different. What we just did was plus or minus 9. What would this one be? This one would be this one plus or minus 9i. Why? Because the right-hand side is negative. When you take the square root of a negative, it becomes positive. Let's do 2 more of these, and then we'll look at some others that are a little bit more complicated. How about we want to solve, and we'll put a negative here. How about we want to solve x squared equals a negative 12? Well, we want to get rid of the square. So what undoes a square? Square root. Whenever we take a square root, what do we add in? Plus minus. And we talked about this earlier today. When we take the square root of a negative number, we're going to have an I. So let's break down the 12 first. And how does 12 break down? 12 breaks down to 3 and 4, and 4 is a perfect square of what? 2 and 2. So the 2's come out. So the 2's come out, so that's going to be a plus or minus. Make sure you use the plus or minus here. 2, it's negative, so an I comes out as well. And what doesn't have a pair with it? 3. So there is your answer. Do what now? Is everyone all right so far? Okay. Yep. So just make sure. Is everyone okay with how I'm doing these? Do what now? Sure. Yep. I'll leave it up there. Okay. I'll leave those up there for just a second. So what we're talking about again is the square root property. So when we take a square, when we have a square, how do we get rid of it? We use the square root. And remember, if you ever miss some of these notes, you can go online and look in Canvas. You can always get the notes in the lecture in your Canvas course. So if you ever miss something, you can always go back and look again. So we're looking at the square root property. So let's try another one. The square root property can also be used when we have parentheses. So let's look at this one. So how are we going to solve this one? Well, we're going to use the same technique that we used a moment ago. We're not going to have to FOIL it. We're just going to use the square root property to get rid of that square. So how do we get rid of a square? Square root. Okay. Add in your plus or minus. Is 9 a perfect square? Yes. So that now gives us the square. The square root cancel. So that gives me 5x minus 1 on the left-hand side. And what is the square root of 9? 3. So we still have the plus or minus. Now we need to make sure we get our two equations so that we can get our two solutions. This plus or minus, that really means that we have two equations. We have 5x minus 1 equals 3. And we also have 5x minus 1 equals a negative 3. Because why do we have two equations? Because of the plus or minus. So you're always going to get on these two answers. So we've got our two equations. Now we can solve them. So let's go ahead and get our two solutions. So we're going to begin with our first one. We're going to add that 1. And so that gives me 5x equals 4. We're going to divide by our 5. And now what do we have? Now we have x equals now 4/5. So there's your first one. Okay, so there's that one. And what about the other one? We repeat the same process. We add the 1. So 5x equals a negative 2. We're going to divide by our 5 everywhere. And that leaves me now with x equaling minus 2/5. So there's those. Let's try one more. I've got to still pass out the sign-in sheet, so let me find the sign-in sheet around here somewhere. Just had a moment ago. Okay, so we'll do one more. I'm going to go ahead and pass out the sign-in sheet, so make sure you sign the sign-in sheet. If your name's not on the sign-in sheet, just add it at the bottom. You can just add it today, but everyone should be on the sign-in sheet. I printed these up yesterday, so if you added yesterday, your name may not be on there yet. We're going to do one more. And this will be our last question for today. This will be our last question for today. So when I look at this one, first thing I need to do is I need to get rid of my square. And how do we do that? Square root. So we'll go ahead and use our square root property here to break this down. Now, what do we need to do after that? Then we look at our square root. It's a negative underneath that square root. So what does that tell me then? That tells me that it's going to come out as what? As an I. So that's going to come out as an I. 3 is not going to break down any. What's going to happen on the left? Well, that's going to be 3x plus 5, and square root of 3 doesn't break down, but we have an I square root of 3 there. Now, we do need to get this to where we can write our answer in the correct form. So we're going to go ahead and move things around and solve this out. Don't forget, what else did I forget? I just about forgot. Be very careful. You don't want to do this. What did I forget almost? Plus or minus. So do not forget that plus or minus. I'm going to go ahead and move that 5 over with subtraction. And I'm going to keep the plus or minus in this case. I'm going to do that because this will not break down. So we'll keep it as it is. And that's going to be 3x equals, I move the 5 over. So that's minus 5. And then we have a plus or minus I squared root of 3. So we need to now go ahead and divide by what? Divide by 3. Now the way I want you to write your answer is I want you to split it up into the real part and the imaginary part. So we now have x equals, I'm going to break this down into a real part, which is minus 5/3. And we've got our plus or minus. And then we've got the square root of 3 over 3. I at the end. So when I write my answer, when it's imaginary, what you want to do is make sure that you break it down into the real part and the complex part. And you can leave it with the plus or minus. Now let's talk about our homework. Art, I gave you that new packet. So let's talk about what we have covered so far from your homework. From your homework, we did 1.3. You should be able to do them all. 1.3 is not going to take you more than about 10 minutes to do. There's not much to it. It's very simple. We have also done 1.4, and we did 6 through 10. So we did 1.3, we did them all. 1.4, we did 6 through 10. Now, if you've got your homework, and you want me to go ahead and grade it, so if you've got it finished and you want me to grade it, bring it up to the front, and I'll get it graded and pass it back next class period. If you want to wait and turn it in on Thursday, you can do that. So if you've got your homework done, I'll go ahead and take it. If you want to wait and turn it in on Thursday, you can do that too. So if you've got your homework.
But I won't be there Thursday or Friday.
Okay.
Me and my wisdom teacher now.
Okay.
So I won't be back till Monday.
Come Monday?
But I didn't start study hall until this week.
Okay.
So can I turn it in whenever I come back?
Yep, on Tuesday. Yep, no,
Okay, Tuesday.
yep, that will be a problem.
Okay, thank you.
Yep, thank you. Just make sure the names are on all of these. Yep, and staples up here if you need it. We'll just make sure it's got the name on here. Thank you very much. Thanks on that. Thank you very much. And I'll get these graded probably this afternoon and posted in Canvas. So I'll be working on grading these this afternoon. And you'll probably see your scores in Canvas. If you got some, you can. If you want to attach it, if you don't, that's okay too. Some of these don't require it. Okay? Thank you very much.
Like for the next